look what I have here. This is a helium leak detector. It is from Pfeiffer Vacuum, and as you can see, it is in a pretty bad state. I got it from Pfeiffer Vacuum. They apparently didn't use it anymore, and I want to see if I can repair it. Helium leak detectors are used in high vacuum applications to, as the name suggests, find leaks. The basic operating principle is that you connect your vacuum system at this port, this KF flange right here, and the unit pulls a vacuum on the system, and then you can use helium and release the helium around, for example, a location where you suspect a leak, or in general around flanges. And inside here is a turbomolecular pump, a roughing pump, and also a mass spectrometer which detects helium in very low quantities. So if helium gets through leaks into your system, this thing will detect it and tell you that you have a leak. And I will go into detail how this works if I get to repair it. If I'm not able to repair it, I will probably explain it anyway. So let's see if we can get this to work again. The first thing I'm going to do is firstly clean it up a little bit and then open it up, because there is a roughing pump, a rotary vane pump, and I want to see if the oil in there is still good, so I won't damage it by turning it on. I'm pretty excited to see the state of the unit inside. So let's take a look. Maybe put the camera a little bit closer. Just like that. There is a ground wire right here, which I can remove. As you can see, we have a rotary vane roughing pump in the back here, which provides the necessary vacuum for the turbomolecular pump to work properly. This way you should be able to see the unit a little bit better. Here you can see the turbomolecular pump. It is a Pfeiffer TMH071, and as I've said before, the roughing pump in the back is necessary to run the turbomolecular pump. And here, this should be, if I'm not mistaken, the mass spectrometer to detect the helium. We have some magnetic valves right here to open and close the system. And to be honest, the state of the unit looks pretty good.
You're wrong.
The oil glass is visible from the side. It seems like there's no oil left in the pump. Maybe somebody removed the oil from the system before putting it in storage. Down here you can see the exhaust filter, and it looks suspiciously clean, to be honest. I would expect to see a lot of oil in there, and this filter here, maybe somebody changed it, almost looks unused. Here you can see the oil, let's call it release valve, to empty the oil in the pump. And yeah, maybe somebody used it to drain the oil from the pump, because as I've said, there's nothing inside. And by the looks of the refill port on the top, as you can see, it's a little bit mangled up. There was somebody in here and changed the oil, or maybe just opened it up to release the oil. So I've got some LVO 100 vacuum pump oil, and I will refill this vacuum pump. And by the way, I've got an even more awesomer and a better present from Pfeiffer Vacuum. You will see it in a later video. And no, this is not for advertisement. He didn't even ask me to mention his name whatsoever. I asked him if it's okay if I mention his company, so he just did it from the kindness of his heart. So I have now refilled the pump, and I also drained around 100 milliliters of oil back out through the port at the bottom of the pump to see if there's any leftover old oil and if I need to flush the pump. But the oil coming out basically looked the same as the oil I filled in. So this pump was definitely well taken care of. You can also see it, well, you can't see it because there is a fan in the front. But if you look through the oil glass of the pump, there's no corrosion, no grime inside. So yeah, I don't think it's necessary to flush the pump with oil. So now I think I will just try to turn it on. I have very loosely connected the one loose wire back on, because I just want to see if the system works at all. Wish me luck. Okay, the fans are spinning. The rotary vane pump just turned on. I've turned it back off. It was telling me that the turbomolecular pump was spinning up. It would take 2 minutes, but what I saw was that in this tube right here, which connects the turbomolecular pump to the rotary vane pump, there was a liquid, probably oil. It was flowing in this direction, like some fluid was trapped in there and was pushed up by the flow the turbomolecular pump produces. So maybe this unit was tilted in a way that caused oil to flow in here, and that's of course, well, it sucks. I will take off this hose right here and see if and how much oil is in there. In my opinion, there shouldn't be any oil here, so we will see. I'm sure I didn't imagine it. I can't see any obvious signs of oil right now, but yeah, this is damn, there's definitely oil in this hose right here, which is not good. Yeah, you can see. Yeah, you can probably not see because of the camera, but there's oil all around this piece right here. That sucks. I mean, I don't know, maybe there's supposed to be oil inside, but I highly doubt it. Seriously, can't imagine that this is supposed to be filled with oil. It's basically up to the threads of this fitting here. There's so much oil inside. I'm beginning to think that maybe there is supposed to be oil inside, but as I said, I'm going to look it up in the manual. So, who would have thought, according to the manual, this is the valve block, and there's not supposed to be any oil inside. At least they don't mention it. I'm beginning to suspect that nobody drained the oil of the pump, but maybe this unit was stored on its side, and all the oil drained in this valve block, and worst case scenario, it drained inside the turbomolecular pump, which basically ruins it. And cleaning this is, as far as I can tell, a pain, because I would have to remove all this stuff right here, but I think that's what I'm going to do. I don't want to run this thing with oil in here. If this pump isn't already ruined and flooded with oil, it will be if I run it in this state. So I'm going to take off all these valves right here and see if I can clean it. Oh yeah, you can see the oil flowing out of there. Not sure if you can see it, but inside there are the veins of the turbomolecular pump. Yeah, there's oil inside everywhere there. Another question is if oil got into the mass spectrometer. If it did, yeah, I think I will try to take off the turbomolecular pump from the mass spectrometer. I'm not filming for 1 second, and you're not seeing the shot of the oil draining out of this valve here. When I removed it, yeah, this, I think all of the oil of the pump is inside this. Yeah. Man, that's a bummer. So guys, I'm sorry for not including you in removing the whole valve block assembly and the turbomolecular pump, but I just had to get myself familiar with everything here, and the camera angle is not the best and the tripod is always in the way, so I just needed some time to get this done. As you may be able to see, I've removed the turbomolecular pump, the valve block, and the valve block was basically filled to the top with oil. There's a drain plug at the bottom here, and when I removed it, oil came flowing out, and at first I felt like I'm being gaslit by this valve block because, yeah, it's not an oil drain valve, but it seemed like one. And the good news is that I think the helium calibration leak here is oil-free. I couldn't see any oil in it. All of the valves, basically, yeah, I have to clean them in organic solvent. They are, yeah. You can probably not see it, but this felt pad here is completely filled with oil. I think I'm just going to throw it away. Not sure where that oil came from, to be honest. Okay, great. I'm now going to remove the power supply. There's so much filth inside. Okay, so some good news. The mass spectrometer does not seem to have been in contact with any oil. I've just taken a look inside and everything here looks clean. By the way, I'm very sorry about the audio quality. I know I have to get a lavalier mic, but currently I simply do not have the money for it. And I'm also sorry for the bad camera angles. I wish I had an over-the-top camera mounted, but yeah, that's everything I can do right now. To prevent any contamination from getting inside the mass spectrometer, I'm just going to close it up with some aluminum foil. Here you can see the valve block with all the valves removed. I still have to remove this thing right here. The screws here were mangled up, so I couldn't get them out. Maybe a Torx inside this hex will work. And yeah, you can see that my fingers, but other than that, the valve block looks great. It's a pretty sexy part, isn't it? I mean, machined out of solid aluminum. I like it. And while my gloves are still oily, these are all the magnetic valves, the solenoids I pulled out, and all of them are yeah, oily, and I will also have to clean them. Here I have to take a look at the polymer used, because I don't want to dissolve it by the organic solvent, and there are also some O-rings I don't want to damage. so I will think about what I can use. Now with some fresh gloves on, let me show you the turbomolecular pump. The side connected to the mass spectrometer looks fine. I can't see any sign of oil. This side here, I already wiped it off, was pretty oily. Let me just clean this whole pump a little bit before I show it to you. Okay, I think that's clean enough for now. Here you can see the port leading to the mass spectrometer, and you can see the veins inside. And this is the side connected to the valve block, which was flooded with oil. For a second I really hope that there is not even oil inside. Yeah, there's definitely oil inside, which is quite a bummer. I really hoped to be able to just clean this thing up from the outside. But yeah, I talked to Spirit, which is one of the most knowledgeable persons I know regarding turbomolecular pumps and their disassembly, and he said that the Pfeiffer pumps are a pain to disassemble and reassemble and often break when doing so. I think I will attempt to open it up. For that I first have to remove the controller. Yep. Let me just remove these two screws also. And there we have the bare pump. I will put this flange back on here, just so we don't lose the screws. This is definitely one of those projects where you don't want to have 3 extra screws left after reassembling everything. I know that by removing this plastic cap here, one can get to the wicks which hold the oil. It is a real shame that manufacturers of those items do not publish manuals which in detail explain the disassembly of their product, and I don't really get why. I mean, I bought it, it's mine. If I want to disassemble it, I think it's my choice, and I would be grateful if they provided me with some instructions. Oh man, that was way easier than I thought. Okay, so is that oil? There's oil down here. The problem is I think the stators are shiny, but there are definitely droplets on there. Yeah, it feels, you can see it maybe on my fingers. Yeah, the whole thing is oily. So I'm not angry at myself for taking it apart, because it definitely needed to be taken apart to deep clean it. So, what do we do next? I feel like we have to pull a bearing or something down here. Maybe that's what I should have started with. I will just put this back on. So I won't damage. Oh man. Anything? Let's hope. Okay, there's one very calming fact. The rotor, when I pulled this out, did not spin freely and interfered with the stators. But as soon as I push the, I think it's a magnetic bearing back in, it spins freely. So I didn't destroy it, so there's that. Now I just have to remove this white cap, I think. Great. Awesome. Okay, there are 4 screws, which I do not know what they are for. But if there are screws, they can be removed. It's just like buttons. Buttons are there to be pushed, and screws are there to be removed. Jesus, I see coming that I completely destroy this turbo, and the comments will absolutely hate me. Some good news, I was able to pull out the oil cartridge with a screw in the middle. And interesting thing, you can see that these wicks here have little fingers pointing to the inside, which enables this conical shaft right here to pull up oil inside the bearing. I'm now going to place the oil cartridge inside a tiny bag to keep it from losing its oil. And if I understood Spirit correctly, this tiny hex inside is the bearing nut, which apparently can be man, I don't feel good about this. And another thing is that, okay, the stators are different heights, so I definitely need to mark them. The problem is, I can't mark them with a permanent marker because I will have to clean this in solvent. So I will try to mark it by scraping it. Oh, that worked better than I thought. I feel like to unscrew this I have to block the rotor from spinning, and I'm a little bit scared that I'm going to damage something by doing that. Okay, that sounded, well, not great, but promising. Okay. Okay. Am I able to just pull this out now? I think I have to 3D print a tool to push this bearing out right here. Okay. Whew. Man, that's a little nerve-wracking. Okay, so I 3D printed this part right here, which is basically a bearing pusher. Or a shaft pusher, because I wanted to try to push this shaft here out. I'm still not sure if it's the correct way to do it, but I will try to use a little force to push it out. But before I do that, let me remove these ports on the side, just to be extra sure that they are not the reason that this rotor is not coming free. And here you can also see the, I'm not sure if you can see it, but the amount of oil in here, yeah. So the way I designed this is that I can use the original screws screw it in the existing screw holes, and then I can use this shaft right here and screw it in to push against the shaft. Okay, that does seem to work. Yep. Okay. So. Here you can also see the oil on top of the stator. Okay, I think that's all the stators. But I think I have to push the bearing a little more. Yep. Here you can see all the oil. This is the molecular drag stage, if I'm not mistaken. Here we have even more stators, if I'm seeing this correctly. This is the molecular drag stage. I think yeah, it's just a beautiful piece of equipment, but full of oil. To be honest, the top part doesn't look that bad. There's a little bit of oil inside, but not that much. Now I can get to clean it and then reassemble it. And reassembling it will definitely be the interesting part. I think I'm going to wash them one after another to be able to keep track of everything and not mix them up. It's just... a turbomolecular pump, I think, is one of the most beautiful pieces of equipment you can find. The tolerances and the speed at which it's spinning is just, yeah, it's awesome. Okay, I have now cleaned all the parts with acetone and isopropyl alcohol. Besides the base here, I only cleaned it with isopropyl alcohol because the acetone can damage the coating on the wires here and make them to short out. And Spirit told me that you also, under no circumstances, should wash the rotor with acetone because the molecular drag stage down here is a carbon fiber composite material and it gets damaged by acetone. Well, that was an hour after I soaked it in acetone for 20 minutes. So I really hope I didn't damage the molecular drag stage. It feels and sounds okay, but well, there's only so much you can tell by the sound and the feel of a material. Yeah, we will see. If you ever attempt to clean your turbomolecular pump, do not wash the molecular drag stage with acetone. Before reassembling the turbomolecular pump, or attempting to reassemble it, I'm going to lube the bearing, or pre-lube it, because due to the solvent there's no lubrication left in the bearing, and when I put it together, sure, sooner or later the oil reservoir at the bottom will bring oil to the bearing, but I want it to be lubricated from the start. So I'm going to use a little bit of rotary vane pump oil, just the smallest amount, to lubricate the bearing. I don't think you, or as far as I know, you don't need a special oil. As long as the oil has a lower vapor pressure than the 4-line, it should be fine, because there's no high vacuum down here. The question now is how to start. I know that this part screws down at the bottom right here. So I think I'm going to start with that. And then this goes over the top. And then comes this part. Yeah, so I think the first thing I'm going to do is screw down the part right here. This is the O-ring, which sits right here. And I think I will also use a little bit of oil or ultra-high vacuum grease to seal it. I have this Apieson ultra-high vacuum grease. I will just use a tiny amount to lubricate the O-ring. Then of course change the gloves so I don't contaminate any other parts with the grease. I just changed the mic on my camera and I really hope the quality is a little bit better now. I just noticed that I checked the wrong reference picture. This port right here is supposed to align with the inlet port, or the outlet port to the 4-line pump. Okay, so now the stators and everything else needs to be assembled. What worries me, I'm pretty sure you can't see it, but they are slightly bent. You know, they are not fully planar, they are bent like this. And I'm not sure if it's supposed to be that way, or if that happened when disassembling it, but I was very careful not to bend anything, and they appear to require at least some force to bend. So I think I'm going to leave them that way, not knowing if it might cause problems later on. Maybe it's supposed to create some sort of preload when the stack gets pressed together, but I honestly don't know. the last stators. Perfect. These stators here overlap. That's not how it's supposed to be. Okay. Now comes the, in my opinion, most nerve-wracking part. This whole thing here only seats correctly if I push it down into the bearing at the bottom. And I'm really not looking forward to do that. I really can't describe to you how annoying it is to get all the stators in the correct position. And once again checking all the stators to make sure they don't overlap. Okay. That didn't feel that bad. I think I took probably 15 minutes with a cannula to align all the stators. Some of them were not sitting in their little ridge on the centering rings here. But now everything looks and feels right. Let's put on the top magnetic bearing. Make sure there's no dust or anything else inside. Okay, before we put the housing back on, I need to reinstall the bearing nut, which is this conical piece here I removed earlier, and it has a reversed thread. It kind of threw me off in the beginning when I tried to disassemble it. And yeah, I'm very sure there is a torque specification for this bolt, but yeah, I mean, due to the reverse thread, it should be self-tightening when this thing spins. It turns freely. Take a look in here. You can see that there's no resistance, so there are no stators rubbing on the rotor. So I think we are good. Okay, I just had to take this thing apart again, at least remove the housing, because I forgot to put in those 3 screws on the inside here, and they were not aligned with their corresponding holes, so yeah, don't forget these screws. And now I'm going to reassemble everything. The last step for this bottom part right here is to reinsert the oil cartridge. I'm not sure if the alignment is crucial, I don't think so, but I'm still going to use a reference picture to get it the same as it was before. Perfect. And now the last O-ring at the bottom is this one right here. And again, I'm going to use some ultra high vacuum grease. It has a vapor pressure of 7 × 10 to the power of -11 torr at 20 degrees Celsius. So it's plenty good for the low vacuum side. And screw it down, of course, using the wrong tool. I will now reattach the valve block. I have also cleaned with organic solvents and dried. So yeah, let's do that next. It still looks sturdy, but yeah, trust me, I thoroughly cleaned it. And it's mostly on the outside. I think it's the grime that was all over the machine on the inside. I just noticed that before I can install the valve block, I have to put the plug right here back, which plugs into the valve block. It's this one right here. And now we get to the valves. Here are all of the pistons for the valves. Interestingly, valve 2 and 6 had these tiny green rubber things in them. I'm not sure what they are for, but of course we're going to put them back where they came from. I'm sorry for the pump running in the background, but I'm testing the rotary vane pump currently. The last step is to attach the mass spectrometer to the turbomolecular pump, because I want this system to be closed up and not have an opening to the high vacuum side all the time. This right here was the seal between the turbomolecular pump and the mass spectrometer. I'm not sure, I think it's a one-time use item, but yeah, I guess if I buy this from Pfeiffer, they're going to charge me quite a lot. And besides that, they are not even, won't even sell it to me because I'm not a company. So I will try to reuse it. So with that done and having cleaned the inside a little bit, I think it's time to put everything back together, starting with the mass spectrometer and the turbomolecular pump. There are 3 screws that hold the turbomolecular pump to the bottom of the housing, and the mass spectrometer itself is not screwed down. It is held by 2 slots in this metal housing right here. I correct myself, there are 4 screws. I just had forgotten about one. With that done, I can reconnect the turbomolecular pump. And there's a second connector for the turbomolecular pump, which can be plugged in on the opposite side. And the mass spectrometer also has two connectors here and there. And a third one actually, which is, I think, just a ground wire. Yeah, which is a ground wire connected to a post at the top here. The next step is to reattach this block right here. It goes below the valve at the bottom here. And it had these two golden pins in here. And this is actually not a solenoid valve, but a holder for these two, I think they are Pirani gauges. They have small little wires inside. And I really hope that they did not get damaged by the oil inside and them turning on. So I washed them with isopropyl alcohol and acetone. So let's hope they didn't get permanently damaged, because if so, of course the system will detect an error or a fault, because it can't tell the pressure, and that would really be a bummer. Okay. We are almost done with the valve block. One of the last steps is to put the helium calibration leak back on. So let's do that. So finally, actually the last step for the valve block is to reattach this venting line here. I of course also cleaned all of these hoses with acetone and isopropyl alcohol. It would probably be best to replace them, but I don't have a hose this size. Next step is putting the power supply back in. With that done, the last step is basically to mount the rotary vane pump. And I checked the pump. I've let it run for maybe 30 minutes to get it to warm up. It wasn't leaking any oil down here, and it also didn't spew any oil out the inlet port here. So I'm not sure what caused the oil to get into the turbomolecular pump and the valve block. But I don't think that this pump will immediately spew oil back into the valve block, hopefully. Oh, the only thing wrong with this pump is that this, I don't know what the English word is, Zugentlastung, this cable fixing thing here is broken. I will replace it if everything else works, but I don't think it's worth buying this. Or maybe I should even have a part that could fit. But I will first test if everything else works. And the pump plugs back in with this cable here in the house, on this PCB here. Next comes the fan and the oil mist eliminator for the exhaust. Regarding the hose for the 4-line pump, which connects the roughing pump to the turbomolecular pump or the valve block, I will reuse this one here. I cleaned it with acetone and isopropyl alcohol and left it to dry. It would be best to replace it. I don't have this hose right here. I have a silicone tubing which fits, but I don't want to change it right now. So the last connection we have to make before we can test the whole system is the connection of the 4-line pump to the valve block. Okay, it's the moment of truth. Everything is assembled. I connected the display, and I'm also filming the display with a phone, just so you're able to see better what's on there. I will probably put it in one of the corners of the video. And all that's left is to plug it in and turn it on and see if the system runs. And just in case the turbomolecular pump tries to kill me, it is facing away from me, and I'm also wearing a face shield and safety glasses. And of course I will squint. Here goes nothing. The display is not showing anything. It sounds like the turbomolecular pump is spinning up. I'm not sure if there's a loose contact somewhere. I was the idiot. I was clamping it here and I probably pushed on the LCD screen. And now you should be able to see the display. According to the display, the last calibration was done 2011, so 12 years ago. So how about we do that first? He's asking me if the test port is closed, and it is. I'm not sure how long this is supposed to take. I'm not sure why it's not working. I just want to play around with it a little bit and to test everything, or to test something. I'm going to use this needle valve. Oh, it's KF16, 1 second. I was certain I own more than one KF25 to KF16 adapter, but apparently not. I just had to take it from my other vacuum pump. And with this needle valve connected, I hopefully can simulate a leak and test this thing. I think I'm just going to press start. Okay, I'm not sure why, but he does not want to start the measurement. It seems like the pressure is not dropping here. Maybe it's one of the valves not working. So I've just checked the solenoid valves right here, especially V2, also valve 2, because it's the one connecting the inlet port here to the roughing pump and pumps it down before it's then open to the turbomolecular pump. And there is this little green thing in there, this rubber pad, and if it's crooked, the valve doesn't work properly. I'm not sure if it was crooked in here. I just made sure that when reattaching it, it was in there correctly. So I will just turn it on and try again. Okay, let's see if the valve actuates this time, or if the valve was even the problem. Oh yeah, great! Awesome! I really didn't think that was the reason. Awesome! That's so freaking cool. Man, that's just... As you can see, I repaired the display, or basically I 3D printed a part which clamps the two halves together and closes the hole in the bottom and gives the whole part way more rigidity. It doesn't bend. And I can just slip it over this metal post right here and still turn the display. And if I want to, I can even use the cord here to extend the display if I want to take it somewhere else, or if this machine is in a place where I can't look at the display. These connectors here, by the way, are LEMO connectors, and they are very expensive. I think this connector was 60 bucks. I didn't buy it. There was an extension cord that came with this machine, and I just used that and mounted it to the display. I also opened up the display and cleaned the LCD from the inside to make sure that there were some dust particles and particles from the plastic inside the housing on the display, and now it looks almost like new. I would like to use this opportunity to thank my Patreons. Many of my projects are expensive and would not be possible without your financial support. If you like my videos and you are not a Patreon yet, I would be very happy if you think about becoming one. I would like to thank Spirit and the other guys from the Vacuum Hackers Discord server for their help. And of course, I would like to thank Pfeiffer Vacuum for their fantastic device. I know, the video is already way too long, and I promise you we will test the device in a few seconds. But there were a couple of points I wanted to address. The test leak, which I called the calibration leak in the video, is not for calibration as far as I understand. An external calibration leak is needed to calibrate the instrument. The internal test leak is only there to test if the calibration is still valid by comparing the measured leak rate with the leak rate of the test leak. So at the moment I have no possibility to calibrate the device, but maybe this will change in the future. Another thing is that, as you have seen, I'm not an expert in the field of turbomolecular pumps, and I intentionally left all my failures and wrong attempts to disassemble the pump in the video, because I think it's a way for others to learn. So let's pretend this here is our vacuum system and we have properly built it, so we don't expect any leaks. Let's test for that. I will start the measurement. There's, I think, still helium around the machine from my previous test, but as you can see, the graph doesn't change right now. Let's put some helium from this helium bottle around the flanges and see if the graph changes. And as you can see, the graph doesn't change because no helium is entering the system. It's actually falling because the helium that was introduced in my earlier test is still inside the system. Let's stop our test. And now I will pretend that I didn't assemble the vacuum system correctly. To simulate a leak, what I will do is put a small piece of kitchen cloth that is only one layer, it's not thick, between the sealing surface and the O-ring, just like if there was a hair or some dirt when assembling the vacuum system. So let's use some helium and release it around the flanges and see where our leak is. Let's just pretend we don't know where the leak is. And you can see, as soon as I release the helium around the leak I've earlier created, the graph shows it because helium is getting into the vacuum system through the leak and is being detected by the mass spectrometer. As soon as I remove the helium, the graph goes back down. We can do that again. And you can see that the graph rises. And if I remove the helium, it falls back down again. This was definitely my longest video so far, and I don't even know if people are still watching. But for those of you who are still here, I thought I would give you a little sneak peek of my other new project. Isn't she beautiful? Thank you a lot for watching.